All right. Today's topic is factoring quadratic expressions. The way usually people factor quadratic expressions is if, say, you need to factor x squared plus 5x plus 6, they say, hey, just write x plus something, x plus blank and x plus blank. And now come up with two numbers that multiplied, you get 6, and when you add them, you get 5. See that constant 6 here in the middle number, the coefficient of x is 5. So what two numbers multiplied, you get 6, and what when you add, you get 5. People come up with 2 and 3. Yes, perfect. And the teacher says, yep. So the answer is x plus 2 times x plus 3. But I want to say that there's a small problem with that. Suppose you needed to factor 6x squared plus 5x minus 4. In that case, what are you going to write? X and 6x, or 2x and 3x, or all kinds of possible combinations exist, right? So what would work? And that's why I think it's better to use a consistent method. What I'm going to do is use that consistent method to solve first that simple problem x squared plus 5x plus 6. So the first step in that is if you want to factor ax squared plus bx plus c, you need to first find a times c. Okay, so a is the coefficient of x squared and c is the constant. Find that product. So in our case, x squared plus 5x plus 6, a is 1 and c is 6, so ac is equal to 6. You right? Then you need to find a set of unordered pairs fi comma gi such that f sub I times g sub I is equal to ac. That probably looked a little scary to some people, right? There's nothing to be scared about. Let me explain what I mean by that. So the next step is to take that AC, which is 6 in our case, and ask yourselves, what can you write 6 as a product of two numbers? In what all possible ways can you do that? 1 times 6 is 6. Negative 1 times negative 6 is also positive 6. So is 2 times 3 and negative 2 times negative 3, right? So list all those possibilities. And then out of these possibilities, which pair adds up to that middle term b, the coefficient of x? That is the next step. From that pair, from that set, pick a pair that satisfies this condition. F sub I plus G sub I is equal to B. In our case, 2 plus 3 is equal to 5. Okay. In fact, this is not very different up until this point, what you probably learned. But here is where we are going to do something slightly different. That is, we are not going to just write down the answer as x plus 2 times x plus 3. Instead, we are going to say, split that 5x as 2x plus 3x. See, you have x squared plus 5x plus 6. Write that as x squared plus 2x plus 3x plus 6. And then you factor by grouping. That is, you take the first two terms, in this case x squared plus 2x. What can you factor out of that? You can factor out an x. So you get x times x plus 2. From the last two terms, 3x plus 6, what can you factor out? A 3. So 3 times x plus 2. In other words, you say x times x plus 2 plus 3 times x plus 2. Now notice, we have a slightly miraculous thing that's happening, which is that same x plus 2 shows up in both the terms, x times x plus 2 and 3 times x plus 2. So which means we can factor out an x plus 2 once again. And if we do that, you get x plus 2 times x from the first term and plus 3 from the second term. That's it. Okay? I agree. This may have had a couple of extra steps of splitting that 5x into 2x and 3x when that was not necessary. But That method of just simply writing x plus 2 times x plus 3 wouldn't work if the coefficient a is the coefficient of x square a is not equal to 1. And that's the whole idea. So let's look at this example. 6x squared plus 5x minus 4, right? So the first thing is a times c is negative 24. Negative 24 can be written negative 24. Uh-oh, I made a mistake. I said thus 24 is equal to, that should be negative 24 equals, I'm sorry about that. 1 times negative 24, negative 1 times 24, 2 times negative 12, all these possibilities. Of these, which pair, when added up, you get the middle term 5, negative 3 and 8. You agree? So we split that middle term 5x as negative 3x plus 8x in this case. In other words, 6 times negative 4 is negative 24, and also negative 3 times 8 is negative 24. Negative 3x plus 8x is positive 5x. So that's why this is a good way of splitting that middle term. And after that, you just group and factor. Group the first two terms and factor, you get the answer. Cool. I'm going to list, usually, I'm not going to write down step one, step two, and all of that. How do I practically do this given a problem like this? So I go to the side and figure out a times c is negative 18. And okay, negative 18, 1 and negative 18, negative 1 and 18. I keep repeating this. I start with a 1 and immediately negative 1. 1 times negative 18 is obviously one way of writing negative 18 and so on. But each time as I write, I do add up the numbers as well. 1 plus negative 18 is negative 17. And I take a glance at my b. Is that what b is? Nope. B is negative 3, but 1 plus negative 18 is negative 17. Similarly, negative 1 plus 18 doesn't work. 2 and negative 9, and negative 7 and positive 7, nah. 3 and negative 6, aha, that works, right? So the moment one combination works, I stop. We don't need to list all the possibilities. And as usual, the next steps are splitting the middle term as 3x minus 6x in this case, factoring by grouping. Factor out a 3x from the first two and a negative 2 from the last two, and you end up with a 3x plus 1 as a common factor. Factor that again, and you're left with 3x plus 1 times 3x minus 2. That's it. Thank you.